Intralog that is digital twin for Intralogistics, is a component developed as part of the Shop Floor CFS Smart Human-Oriented Platform for Connected Factories project. This component is created by the rFactory application implemented for the needs of this project. With the help of this application, data about the factory are collected, transferred to the digital twin of the factory created in LogAbs. The results of the analysis in the digital twin are transmitted to the real factory in the form of recommendations. At the same time, information about resources is transferred by FiWare to the cooperating raw array risk analysis component implemented by IF. The main goal was to design an app for a factolet. The application is intended to enable the collection of layout data or the design of the factory layout by an employee on the factory floor and the sharing of design data directly from the factory floor to the digital twin of the factory. The project was carried out in Poland, in Poznan by PSNC Poznan Supercomputing and Networking Center in the Volkswagen commercial vehicle factory, where the caddy and transporter models are assembled. The digital twin of the factory was built in the LogAbs application, which also includes a 3D simulator. The visible white model is the caddy, the yellow ones are the transporter. Some of the areas of the factory where the project was carried out were the chassis assembly sub-area right-hand side and the engine assembly sub-area right-hand side. The project developed 6 cases related to the human factor in a factory. 3 components were used. rFactory, made by SNC, RAW made by IF, and external component LogAbs. The scheme of activities using components can be described in 6 steps. Step 1. Build digital twin model in LogAbs. Step 2. Use rFactory in real production system to fit the new container, equipment or machine. Pre-save new objects with new coordinations from rFactory to DT LogAbs. Step 4. Do simulation experiment in LogAbs and check solution. Step 5. If necessary, correct positions using rFactory application and repeat steps 34-5 till the end. Step 6. Do RAI analysis for built DT and prepare recommendations for real factory. Working with rFactory involves defining the position and location according to the LogAbs notation, placing the marker on the factory floor, and calibrating the virtual workstation with a real worm. Definition of location dimensions, length, width, selecting the designed shape from the LogAbs database containing the shapes of containers, equipment, and machines displayed in rFactory, placing the shape in the right location. Data collection, design. Case 1 consists in eliminating the bent working position of the operator by using containers with a shelf lifting system. The operator lifted 250 times a weight of 20 kg during a shift. With the new solution, he avoids this. Case 2 consists in eliminating the effort associated with pulling out the shelf with parts and lifting these parts by using a rack with automatic extension and lifting of the shelf, reducing the lifting of the weight by 250 times the weight of 15 kg. Case 3 consists in replacing 2 buffer areas with one by changing the organization of the delivery of chassis components. Introduction of sequences, reduction of the distance covered by the operator by more than 10. Case 4, reduction of the lifted weight and the distance covered also 10 by placing an additional gripper in the crane change. Cases 5 and 6 are for the engine mounting station. Currently, the operator is only supported by vertical movement, raising-owering the engine, while horizontal movement requires the operator's effort. Using rFactory, we show the possibilities of placing a new crane. Case 5 supporting the employee in horizontal movement. Case 6 is a new layout organization related to the introduction of sequences, a complete reduction of manual operations related to the movement of the engine, a reduction in the distances covered by the employee, and a reduction in warehouse space. Integration with the raw component. Risk analysis is based on the fact that the resources used in the digital twin previously introduced, designed with the use of rFactory, are automatically exported by FiWare to the RA component, where the risk assessment can be performed. View of the layout of the Volkswagen factory in Rzesznia, near Poznan. two employees carry out similar tasks, one moving a container of parts by hand, the other using a pallet machine. Information about employees, locations, containers, and equipment is exported automatically by selecting the position and resources in the digital twin database and starting the transmission by firewire. The exported file with the asset information is visible on the screen. Thank you, and we look forward to working with you.